The purpose of this video is to help you understand amortization better. First, let's look at its definition. Amortization is the process of decreasing a lump sum loan with a fixed payment using a periodic payment schedule. Although the fixed payment doesn't have to be the same amount each time, this is what we are going to be working with. An amortization schedule is a table that details the periodic payments of the loan. It shows the amount of interest and the amount of principal contained in each installment or payment. One of the first things that we will need to do is find out how much each periodic payment should be. To do that, we need this formula. Okay, where A represents the present value, R represents the value of each regular payment, N represents the number of payments, and I represents the interest rate per conversion period. Now, since R represents the value of each regular payment, if this is what we need to find, you would want to isolate this equation for R, which means multiplying both sides of the equation by I and then dividing both sides of the equation by this quantity in the numerator. And you end up with this, okay? And that's how you calculate the periodic payment. Okay, let's look at some applications. Read example 1. Okay. So we're being asked to find the regular payment, R. So we'll use this formula right here. Okay. And A is $50,000. Okay. I is the interest rate per conversion period. So it's 8% as a decimal divided by 1 year, since interest is only calculated once a year. N represents the number of payments, which in this case is 5. The loan is to be repaid over a 5-year period. Okay, so let's follow the formula. So it equals A times I divided by 1 minus parenthesis 1 plus I to the power of negative n. Close it twice, and we end up with $12,522.82. Okay, so at the end of each year, the regular payment that must be paid is this amount right here. Now, let's verify all this by showing that $50,000 is actually going to be repaid over the 5-year period under these conditions. So to do this, we're going to create an amortization schedule. Okay, I've already set this up. You want to keep track of the periods, and for each period you want to keep track of the outstanding principal that is still due. You want to keep track of how much interest was in each payment. You want to keep track of the payment amount, that's the $12,000 figure, and you also want to keep track of the amount of principal in each payment. Okay? So, when this first begins, the outstanding principal is $50,000. Okay? And the interest due is 8% of that. And the payment amount is the 12,000 figure. Okay. And remember that if interest is compounded several times per year, don't forget to divide I by that, the number of periods per year. Okay. Now, at the end of each year, a payment of $12,522.82 is paid. Part of that payment is interest, and the rest of it is principal. We've already calculated that $4,000 of this particular payment is interest, so the rest of it is the amount of principal. So we want to take this figure minus this one. Okay, does that make sense? This payment, this $12,000 payment, consists of a certain portion which is principal and a certain portion of it which is interest. And this is going to change each time because now, since $8,000 approximately in principal has been paid, we don't have as much outstanding principal anymore. In fact, we have this minus this much. Okay? So when interest is calculated, it's calculated on the outstanding principal. So less interest in the next payment. Okay. Which also means that more of the second payment consists of principal. You see? Okay, let's go to period 3. The outstanding principal is this amount minus this amount. So the outstanding principal has been reduced. Find the interest on that. Okay, there's the payment. And part of that payment is the $2,500, and the rest of it is principal. Okay. And keep going. So take this minus that. Okay. Calculate interest on that. There's our regular payment. And the principal. Wow. Okay. So last line. We're going to see if we did everything okay. Okay, so this is the outstanding principal minus the portion of principal reduced. Okay, the interest due is the outstanding principal times 8%. The payment amount was still the 12,000 figure. And the portion of principal reduced is this minus the portion of interest. Okay? And look, the outstanding principal and the portion of principal reduced is the same. Let's check one other thing. Let's find the total of this column. $50,000. Okay, so a principal of $50,000 was paid. Okay. Now let's look at one other thing. How much was really paid? Okay, so if we sum up the payment amount column, we find out that to have this loan, you actually ended up paying $62,000, $614.11. So this, the excess, of course, is the interest for the privilege of borrowing the $50,000. Okay? It's a lot more than you think it is sometimes. Okay, let's look at a second example. Read example 2. Okay, now here's a situation where a couple borrows a certain lump sum and they need to know how much the monthly payments will be in order to pay it back in 30 years. Okay? So the present value, A, is the $120,000. The interest rate per conversion period is 9%, but computations are made at the end of each month, so divide that by 12. And they're going to repay the loan in 30 years. So the number of payments is 30 years times 12 times a year. Okay? Let's follow the formula. Okay, it's equal to parenthesis A times I. All of that is divided by 1 minus parenthesis 1 plus I to the power of negative n. Close it twice, and there you have it. So the regular payment is $965.55 each month. So that's what they're going to have to pay each month in order to pay back the $120,000 plus the interest. Let's look at another application. Read example 3. Okay, and you need to understand the definition of equity, and it's given here. It's the value of a property minus the owner's outstanding mortgage balance. And so we need to find out what the outstanding mortgage balance is in order to calculate the equity. Okay? So a 20% down payment was made. So let's find 20% of $200,000. Okay, so they made a down payment of $40,000. Therefore, since the home was purchased for $200,000, the loan amount is $200,000 minus the down payment. Okay, so the loan amount is $160,000, and that's the value of the present, that is your present value, A. Okay? I is the interest rate per conversion period, so it's 9%, and it's compounded monthly, so divide by 12. And N is equal to 30 years of payments times 12 times a year, 360 in all. All right, let's find the regular payment amount. Following the formula, R is equal to parenthesis A times I divided by parenthesis 1 minus parenthesis 1 plus I to the power of negative n. Close it twice. Okay, there we have the value of the regular payment. So now they've been making payments already. Okay, let's see. The home was purchased 10 years ago. So they've been paying on the house for 10 years of the 30 years. So 10 years times 12 payments a year means that they've already made 120 payments. And since there's 360 total, and they've already made 120 payments, 240 payments remain. Okay. Now the outstanding principal equals the sum of the present values of the remaining installments, of the remaining 240 payments. Okay? So, all right, so we're going to find the present value. Okay, so we're going to use the present value formula, and we need to know what these things are. So R is equal to the regular payment, which we now know to be this number right here. Okay. I stands for the interest rate per conversion period, so it's still 9% divided by 12. And N is 240, because 240 payments remain. Okay. So now we're going to follow the formula for present value, this one right here. So the present value is equal to R times parenthesis 1 minus parenthesis 1 plus I, okay, to the power of negative N, close it twice, and divide it by I. Okay. All right, so this is the sum of the present values. This is the present value of the remaining installments. Okay, so equity was defined as the value of a property minus the owner's outstanding mortgage balance. So the owner's outstanding mortgage balance is this $143,000 figure. Okay, we now have all the pieces we need to calculate the equity. We know what the value of the property is. We have just found the outstanding mortgage balance. And we also can't forget that the couple made a $40,000 down payment. So let's make the final calculation. The value of the property was $200,000 minus the outstanding mortgage balance, and then plus the $40,000 down payment. And that's how much equity they have in the home. Let's go on now and look at a final application. Okay, read the problem. All right, this couple knows that they can afford $1,000 for monthly house payment, but they need to know the value, the maximum value that they can borrow from the bank. So we want to find really the present value of an ordinary annuity. Here's this formula. R is $1,000. That's the regular payment they know they can afford. The interest rate is 9.6. Okay. % per year, but it's compounded monthly. Okay, and N is equal to 30 years. That's the duration of the loan times 12 payments per year is 360. Okay, so all we have to do is plug these in and follow the formula as we do that. So it's equal to R times parenthesis 1 minus parenthesis 1 plus I to the power of negative N, close it twice, divide it by I. Okay, so the maximum amount that they can borrow from the bank is this much money. Okay? I hope you've learned something from these applications, and I think you're ready to work on some problems now. Don't forget, if you get stuck on something, to post your questions on the discussion board.